You learn one simple thing, and suddenly you feel like an expert. A few facts click into place. The subject stops looking mysterious. Confidence arrives before experience has even unpacked its bags. But the real answer is far stranger. That sudden certainty is not proof that your brain is broken. It is a side effect of how your brain measures its own knowledge. To judge how well you understand something, you often need many of the same skills required to understand it in the first place. What happens when those skills are still missing? Imagine learning to play chess. At first, the board looks complicated. Then you learn how each piece moves, discover a few opening tricks, and win against another beginner. The game suddenly seems manageable. You can explain pins, forks, and checkmates, so you start feeling that you understand chess itself. Then you play someone experienced. Your clever opening disappears into a position you cannot read. Threats arrive before you notice them, and your plan collapses for reasons you cannot explain. You did not lose knowledge during that game. You gained your first clear view of how much knowledge existed beyond it. That gap between confidence and competence is often connected to the Dunning-Kruger effect. The phrase comes from psychologists Justin Kruger and David Dunning, whose 1999 research examined how accurately people judge their own performance. Participants completed tests involving humor, logical reasoning, and grammar. Afterward, they estimated how well they had done compared with everyone else. The lowest performers made the largest errors in self-assessment. They did not usually believe they were perfect, but they often believed they were much closer to average than their actual scores suggested. The highest performers sometimes underestimated their relative position because tasks that felt easy to them seemed as though they might be easy for everyone. Why would skill distort both views in opposite directions? Kruger and Dunning argued that poor performers faced a double burden. First, they lacked the skills needed to perform well. Second, that same lack of skill made it harder to recognize their mistakes. This ability to evaluate your own thinking is called metacognition, which simply means thinking about how well your thinking is working. Metacognition acts like an internal referee. It checks whether an answer makes sense, whether a memory is reliable, and whether confidence matches evidence. But the referee needs training too. If you do not know the rules of grammar, a badly written sentence may look correct. If you do not understand statistics, a misleading graph may look convincing. If you have never studied music, an out-of-tune performance may sound acceptable. This creates a strange trap. The knowledge that would help you notice the problem is often the same knowledge you have not learned yet. You cannot easily search for a missing piece when you do not know that the piece exists. How can you question an assumption that feels invisible? Consider driving. A new driver may quickly learn how to start the car, stay in a lane, and follow familiar roads. Those basic successes feel meaningful because they are meaningful. But they do not yet reveal how the driver will react to black ice, an unpredictable cyclist, sudden mechanical failure, or a dangerous decision made by another driver. Early learning gives you visible progress. Advanced learning reveals invisible complexity. At the beginning, every new fact feels like a large percentage of the whole subject because the boundaries of the subject are still hidden. Later, each answer exposes several new questions. Expertise often feels less certain because experts can see more ways in which an answer might fail. That does not mean experts lack confidence. A skilled person can be extremely confident when evidence is strong. The difference is that mature confidence usually becomes specific. Instead of saying, "This is definitely true," an expert is more likely to say, "This is likely under these conditions," But these factors could change the result. Does that sound weaker, or does it sound more accurate? The popular internet version of the Dunning-Kruger effect often shows a dramatic mountain labeled Mount Stupid, followed by a deep valley of despair and a slow climb toward wisdom. That picture is memorable, but it was not the graph published in the original study. It also turns a statistical pattern into a fixed story that every learner supposedly follows. Real confidence does not move along one universal roller coaster. You can be well calibrated in one subject and wildly inaccurate in another. You can be an expert programmer and a reckless beginner in nutrition. You can understand judo deeply and still overestimate what you know about investing after watching 3 videos. The effect is not a permanent personality type. It is not a scientific way to label someone stupid. It describes a possible mismatch between performance and self-evaluation within a particular task. The moment you use it only to diagnose other people, you may be demonstrating the very blind spot the idea warns about. There is also an important scientific debate. Some researchers argue that the famous pattern is partly created by statistics. When people are divided into groups based on one imperfect test, very low scores tend to move closer to average when measured again, a tendency called regression to the mean. Measurement error and the common habit of rating yourself above average can also produce curves that resemble the classic effect. In 2002, Joachim Kruger and Ross Miller replicated the basic pattern, but argued that regression and a general better-than-average belief could explain much of it. Later research continued to test whether low performers truly have uniquely poor metacognitive ability, or whether the graph exaggerates that conclusion. Why does this disagreement matter? It matters because a catchy psychological label can become more confident than the evidence behind it. The broad lesson remains useful. Performance and self-assessment are not the same skill. But the strongest version of the claim that beginners are always uniquely blind while experts see themselves clearly is too simple. In 2008, Joyce Erlinger, David Dunning, and several colleagues examined the pattern across additional studies and reviewed earlier results. Their work supported the idea that poor performers often make substantial errors when judging themselves. It also suggested that the problem was especially connected to estimating their own performance rather than simply misunderstanding how everyone else performed. In 2017, Gordon Pennycook and colleagues studied reasoning using questions designed to trigger tempting but incorrect answers. Participants who made the most errors greatly overestimated their performance. Poor reasoning and poor monitoring appeared together. Yet even this does not mean that every confident beginner is irrational, or that every cautious person is wise. A beginner sometimes has good reasons to feel confident. The task may actually be simple. The beginner may have received excellent instruction. An expert can also become overconfident through status, habit, or success in a nearby field. Skill can improve self-knowledge, but it does not grant immunity from ego. Your brain does not directly display a percentage showing how much of reality you understand. It builds confidence from clues. Familiarity is one clue. Speed is another. If an answer comes to mind quickly, it often feels true. If words sound smooth and recognizable, they often feel understood. This is called processing fluency. Information that is easy to process can feel more trustworthy and more familiar than information that requires effort. A short video can create fluency by repeating a clean explanation. Suddenly, the idea feels obvious. But feeling that an explanation is easy to follow is not the same as being able to use it, test it, or defend it. Try a simple experiment. Read an explanation of how a bicycle stays upright. While reading, the sentences may seem perfectly clear. Then close the page and explain the mechanism from beginning to end without using vague phrases. Where did the certainty go? Psychologist Rebecca Lawson demonstrated a related illusion in 2006 by asking people to judge their understanding of everyday objects and then draw how a bicycle works. Many drawings contained impossible frames, disconnected chains, or other mechanical errors. Familiarity with bicycles had created a feeling of understanding that detailed explanation quickly exposed. This gap is sometimes called the illusion of explanatory depth. You feel that you understand a system until you are forced to explain its parts and connections. The same thing happens with toilets, zippers, elections, economies, computer networks, and even your own beliefs. Your knowledge often works like a stage set, convincing from the front, surprisingly shallow from behind. The internet amplifies this problem. You can collect conclusions without collecting the reasoning that produced them. A polished thread, a confident speaker, or a dramatic chart can give you the emotional reward of understanding in minutes. Because the conclusion is now familiar, your brain may mistake recognition for mastery. Algorithms can make the illusion stronger. After you watch one explanation, similar explanations appear. Repetition creates consensus inside your screen, even when the wider evidence is mixed. Soon you may not remember where the claim came from, only that you have heard it many times. When does repeated exposure become borrowed confidence? Social rewards matter too. Uncertainty is often quiet. Confidence is easy to display. A person who says, "There are several possibilities, and the evidence is incomplete," may sound less impressive than someone who announces a simple answer with complete certainty. In groups, confidence can spread faster than accuracy. A bold claim gives everyone something clear to repeat. A careful correction requires background, conditions, and patience. This is why beginners can sometimes dominate discussions, while experienced people add uncomfortable details. But humility does not mean constantly doubting yourself. Permanent self-doubt is not wisdom. The goal is calibration, matching confidence to the quality of your evidence. High confidence is useful when it has survived testing, feedback, and repeated success under changing conditions. Calibration can be trained. First, make predictions before learning the result. Estimate your test score before seeing it. Write down how long a project will take. Give a probability to an outcome instead of saying it will definitely happen. Later, compare the prediction with reality. This creates a feedback loop. Without recorded predictions, your memory quietly edits the past. After an event happens, the result starts feeling more predictable than it really was. You tell yourself that you knew it all along. How can confidence improve when every mistake is rewritten as hidden success? Second, practice retrieval instead of recognition. Do not merely reread notes and enjoy their familiarity. Close the notes and reconstruct the idea. Solve a new problem. Teach the concept without checking the source. The places where your explanation becomes foggy reveal the true edges of your knowledge. Third, seek feedback that contains information. Praise feels good, but specific correction teaches more. "That was wrong" is not enough. You need to know which assumption failed, what evidence you missed, and what a stronger method would look like. Fourth, separate identity from performance. If being wrong means being stupid, your brain will defend the mistake. If being wrong means receiving data, correction becomes less threatening. You are not your latest answer. You are the system that can update it. Fifth, ask what would change your mind. A belief with no possible disconfirming evidence is not being evaluated, it is being protected. Naming the evidence that would matter forces your confidence to become testable. What result would make your favorite explanation less likely? Experts often build habits like these because experience has punished certainty that arrived too early. A scientist designs controls because an exciting result may have another cause. A programmer tests edge cases because code that works once may fail under pressure. A martial artist respects basic technique because small errors become visible against skilled resistance. The deepest twist is that learning does not simply replace confidence with doubt. Good learning replaces vague confidence with structured confidence. You become less certain about broad claims and more certain about precise skills. You stop needing to feel like an expert in everything because you know how expertise is actually built. That process can feel uncomfortable. The first stage of learning offers fast rewards. New vocabulary creates immediate status. The middle stage is slower because practice exposes inconsistency. You notice exceptions, hidden assumptions, and failures that were always present but previously invisible. This discomfort is not evidence that you are getting worse. It may be evidence that your internal measuring tool is getting better. You are not losing intelligence when a subject begins to look more complicated. You are finally seeing its real shape. The Dunning-Kruger effect survives in popular culture because it offers a satisfying explanation for other people's confidence. But its more valuable use is private. It asks you to examine the places where certainty arrived cheaply. It asks whether you have tested the skill or merely learned the language around it. The next time someone speaks with absolute confidence, you do not need to assume that person is incompetent. Check the evidence. Check the track record. Check whether the claim becomes more precise when challenged or merely louder. Then perform the harder check. Turn the same attention toward yourself. Find the subject where a few facts recently clicked into place, where the mystery suddenly disappeared, and where your answers began arriving faster than your questions. You learn one simple thing and suddenly you feel like an expert. But real expertise begins when that feeling becomes a question.